Hi everyone, how are you all? So this is our pumping lemma part 5. This is the last part. In this part, we will do basically practice. We have already seen everything about pumping lemma. Pumping lemma for regular languages. We have seen everything. We have done practice. We have seen the proof. We have seen all the different definitions of pumping lemma. We have seen all the results. So this pumping lemma, we have already covered this pumping lemma. We have already seen this. Complete pumping lemma is over. But now in this session, we are going to do some practice. A lot of practice we will do. And we will see all the GATE previous year questions. These also we will see. And I will tell you what are the type of questions possible from this pumping lemma. Different type of questions that are possible. And we will see how to solve them. Okay. So this is our session. Now, let's start this session now. So we have already seen pumping lemma. Everything about pumping lemma we have already seen. Now let me give you the complete summary. Okay, everything that we have seen, let me summarize that. What was the first point that we have seen? I told you what is a pumping lemma. Pumping lemma is a property. Yes or no? Pumping lemma is a condition, or I can say pumping lemma is a property that is satisfied by every regular language, but it is also satisfied by few non-regular languages. Okay, so very simple. Remember, it is satisfied by every regular language. This pumping lemma, this is a property, this is a condition, this is a test, I can say. This pumping lemma test is satisfied by every regular language, but it is also satisfied by some non-regular languages. Okay, so very simple. So this is the simple point that this pumping lemma, what this pumping lemma says, this pumping lemma says that there is a property, or I can say there is a condition. This pumping lemma gives a condition. Some condition is there. Now, we have already seen that every regular language will pass this condition. Yes or no? Correct? Whatever regular language you take, if you take any regular language, what is a regular language? What is the definition of regular language? Regular language means language for which we can create DFA. Yes or no? For language for which we can create NFA, or we can create regular expression. So regular language means a language for which we can create DFA or NFA or regular expression. So if you take any regular language, for every regular language, what will happen? Every regular language will pass this pumping lemma test. Okay, it will pass this pumping lemma test, or I can say it will pass this pumping lemma condition. This pumping lemma condition. So there is a condition here. Okay, this pumping lemma gives a condition. There is a condition, or you can say property, or you can say statement. So this every regular language will pass this statement. Okay, every regular language will satisfy this pumping lemma. What about non-regular languages? What about the non-regular languages? There are some non-regular languages which can satisfy pumping lemma. Okay, remember there are some. Okay, remember there are some non-regular languages. There are few non-regular languages. Not all. There are some non-regular languages. They also pass this pumping lemma test. They also satisfy this pumping lemma test. Okay, so this is the first point. Now tell me one thing. If a language satisfies pumping lemma, can I say that will be regular? If a language L, let's assume, this is my point. Let's assume you have a language L. You have a language L. And if I say, let's assume you have a language L. Now tell me, if L satisfies pumping lemma, if L satisfies pumping lemma, this pumping lemma, then can I say that L will be regular? Then what you can say? If L satisfies pumping lemma, then you can say L may or may not be regular. Yes or no? If you satisfy pumping lemma, then remember L may or may not be regular. L may be regular, L may be non-regular. So L may or may not be regular. Okay, so this is the point. Now tell me one more thing. If L does not satisfy pumping lemma, then what you can say? If L does not satisfy pumping lemma, okay, if L not satisfy pumping lemma, then what you can say? Then definitely L is non-regular. Then definitely what will happen? Then definitely L is non-regular. Okay, I can say, then definitely what will happen? I can say L is non-regular. Very simple. Then L is non-regular. Because every regular language will satisfy pumping lemma. Yes or no? Every regular language will always satisfy pumping lemma. So if you don't satisfy pumping lemma, then you are non-regular. So this is the simple point. Okay, I hope all these points are clear. Now tell me one more thing. If you are non-regular, then what I can say, if L is non-regular, then what I can say, will it satisfy or will it not satisfy? If L is non-regular, tell me, if L non-regular, then what you can say, will it satisfy or will it not satisfy? It may or may not pass the pumping lemma. Okay, it may or may not pass pumping lemma. It may or may not pass pumping lemma. It may or may not satisfy pumping lemma. Satisfy pumping lemma. Okay, so this is the simple point. Okay, and if it is regular, then what you can say? And if L is regular, then what you can say? Then it will definitely satisfy satisfy pumping lemma. Okay, it will satisfy pumping lemma. Okay, so this is your first point. So this is the summary first point. Now let's see the second point. So you have already seen what is the first point. This is the first point. You can notice this pumping lemma. What this pumping lemma says, notice this pumping lemma says that this will say that every regular language, remember, every regular language has a special property. If you can show that a language does not have this property, then it is guaranteed that it is not regular. This is what pumping lemma says. Yes or no? Every regular language will satisfy pumping lemma. But if a language does not satisfy pumping lemma, then that language will be non-regular. Okay, now let's move on. Now let's see the second point. The second point is actual pumping lemma statement. Yes or no? What is the pumping lemma statement? What pumping lemma says? What pumping lemma says? Pumping lemma says that for any regular language, there is a magical number. Okay, this is what pumping lemma says. We have already seen, many times we have seen this. For any regular language, whatever regular language you take, what will happen? Tell me. There exists a magical number. There exists a magical number n. This n, what we call this magical number? This is your pumping length. There is a magical number pumping length. So there exists a magical number. Okay, this pumping length. So very simple. You can notice positive natural number. So this n is greater than or equal to 1. Very simple. So for any regular language, there exists a magical number. There exists a pumping length such that what will happen? Tell me. Such that for all strings of L whose length is greater than or equal to n, these are your candidate strings. These are your candidate strings. Strings which belong to L and whose length is greater than or equal to pumping length. So for all such strings, what will happen? For every candidate string, what will happen? For every candidate string, you can break it into 3 parts. Okay. Every candidate string can be broken into 3 parts, into 3 pieces. You can see. Okay. So whatever candidate string you take, you can break it into 3 parts, X, Y, Z. These 3 parts you can create. Okay. So whatever candidate string you take, this is your candidate string W. Then this is your candidate string. Then we can break it into 3 parts, X, Y, Z. 3 parts we can create. Okay, so this W is equal to basically, this W I can write as X, Y, Z. Such that what will happen? 3 things will happen. What will happen? Such that this Y part is non-empty. Such that this Y, this part is non-empty. Okay, so I can say this part is non-empty. I can say that length of Y is greater than or equal to 1. Okay, so this Y is not empty. Second point, where this Y will be? Tell me, within which area this Y will be available? Within which area? Within which area? So this Y will be available, I can say, in this area. Means I can say in the first P symbols. I can say in the first N symbols, because we are taking N equal to pumping length. Okay, we are already taking N is your pumping length. Because N is your pumping length. So I can say this XY, remember this XY will be within the first N symbols, within the first N symbols, because N is your pumping length. And what will happen? Third thing, this Y you can repeat any number of times. Yes or no? This Y we can repeat any number of times. This I can repeat any number of times I can repeat. So this X, Y power N, Z, or I can say this X, Y power I, Z, this will belong to L for all I greater than or equal to 0. So this is your property, I can say. Okay, very simple. You can notice. So this is the simple point, that for any regular language, there is a magical number. There is a pumping length N. There exists a magical number such that for all candidate strings, what are the candidate strings? strings which belong to the language and whose length is greater than or equal to pumping length. So for all candidate strings, what will happen? You can break them into 3 pieces such that these 3 properties will be satisfied. Okay, such that these 3 properties will be satisfied. So this is the pumping lemma. We have already seen what is this pumping lemma. Okay, clear? Yes or no? So this is your pumping lemma statement. Now let's see the third property. What was the third property? Tell me. How do we prove the pumping lemma? Tell me. To prove the pumping lemma, which concept we are using? We have already seen the proof, right? This pumping lemma proof we have already seen. We have already seen that pumping lemma is satisfied by regular languages. This pumping lemma test, this is satisfied by all regular languages. You can notice every regular language will satisfy pumping lemma test. Okay, this we have already seen. This proof we have already seen. Okay, so now you tell me one thing. Every regular language will satisfy pumping lemma test. This proof we have already seen. And in this proof, what concept we are using? We are using the concept of pigeonhole principle, right? Yes or no? We are using the concept of pigeonhole principle. How are we using the concept of pigeonhole principle? How? Tell me. Because if you take any candidate strings, then within the first P symbols, what will happen? By pigeonhole principle, some state will repeat. Yes or no? Some state repeats. Some state repeats by pigeonhole principle. Some state repeats by pigeonhole principle. Okay, so this is the point. Agree? Okay, because whatever candidate string you take, this is your candidate string. This is your candidate string. So if you take any candidate string, then you already know that its length is greater than or equal to P. Okay, and it belongs to L. So within the first P symbols, some state will repeat because of pigeonhole principle. Some state will repeat because of pigeonhole principle. So you can notice this pumping lemma for regular languages you can prove using the pigeonhole principle. This we have already seen. Now let's move on. This is the next property. This is the fourth statement. This also we have seen. Read this. If P is a pumping length for language L, then can I say P plus 1 is also pumping length? If P is pumping length, then P plus 1 is also pumping length. So this also we have already seen. So you can notice if language L satisfies pumping lemma and pumping length is P, then every number greater than or equal to P is also pumping length. You can notice. Yes or no? If language L satisfies pumping lemma with pumping length P, then every number greater than or equal to P is also a pumping length. Okay, every number which is greater than or equal to P, that is also a pumping length. This also we have already seen. Now let's see the next one. This also we have seen, right? This point. If L is a language which satisfies pumping lemma, then what will happen? Tell me. L satisfies pumping lemma. L satisfies pumping lemma. Then you can notice minimum pumping length will be greater than or equal to length of shortest string. Actually, it will be strictly greater than. Actually, it will be strictly greater than. Yes or no? Agree? This point we have already seen, if you remember. Minimum pumping length that will be greater than, strictly greater than length of shortest string. Strictly greater. Okay, strictly greater than length of shortest string. This point also we have seen. Okay, this we have already seen in our previous lectures. So very simple point that minimum pumping length. Okay, this minimum pumping length will be greater than, strictly greater than length of shortest string. Okay, so this point we have seen. Now let's see the next point. This is our next point. Tell me one thing. In the proof, we have already seen that if you have a regular language L, this we have already seen in the proof, right? That if you have a regular language L, okay, for any regular language L, there is a minimal DFA. Yes or no? We have a minimal DFA, correct? Let's assume this minimal DFA has M states. Then tell me, in the proof we have already seen this M will work as a pumping length. Yes or no? This we have already seen. For regular language L, if you have a regular language L, then there exists a minimal DFA. This minimal DFA, let's assume this has M states. Then you already know that for this language L, which pumping length will work? Which pumping length will work? This P equal to M. this pumping length will work. So I can say this is a pumping length. Okay, so this number of states is a pumping length. This we have already seen. If you remember, I told you that for any regular language L, number of states in the minimal DFA is a pumping length. Okay, so this number of states in the minimal DFA, this is a pumping length. This is a pumping length for L. Yes or no? Tell me. This point we have already seen in the last class in the proof. This point we have seen in the proof that if you have any regular language L, then there exists a minimal DFA. In this minimal DFA, you have number of states, that is M. Then for this language, this M is a pumping length. For this language, this M is a pumping length. Now tell me, if this M is a pumping length, then what is the minimum pumping length? If M is working as a pumping length for L, what is minimum pumping length? What is minimum pumping length? Tell me. Tell me. So you can see minimum pumping length will be less than or equal to this. Yes or no? See, this M is working as a pumping length. Remember this point. Please understand that. Please understand, number of states is working as pumping length. Number of states in minimal DFA. Number of states, that is M. Okay, number of states M in minimal DFA. In minimal DFA for L is a pumping length. Is a pumping length for L. Is a pumping length for L. Okay, it is a pumping length for L. So what will be minimum pumping length? If this number is pumping length, so minimum will be less than or equal to this. Yes or no? Agree or not? See, number of states, this number of states in minimal DFA, this is a pumping length. This is a pumping length. So minimum will be less than or equal to this. Agree? So I can say, so from here I can say, for L, for language L, the minimum pumping length, what that will be? The minimum pumping length, what that will be? Tell me. The minimum pumping length will be less than or equal to M. Correct? Is this point clear? Let me know. See, you already know this is a pumping length. You already know this is a pumping length. This M, this number of states in the minimal DFA, this is a pumping length. This is a pumping length. So minimum will be less than or equal to this. Minimum pumping length, that will be less than or equal to M. Yes or no? Please tell me, is this clear? Minimum pumping length will be less than or equal to M. So this is the point, simple point, because you already know that M is a pumping length. So minimum will be less than or equal to M. Now you tell me one more thing. Can I say every number greater than or equal to M is also pumping length? Can I say for L, every number greater than or equal to M, every number which is greater than or equal to M is also a pumping length. Is also a pumping length. Okay, it is also a pumping length. Yes or no? Is this point clear? Is this point clear? Let me know. Okay, is this point clear? Let me know. See, some students are not understanding this. Number of states is a pumping length. Number of states is a pumping length. Now remember, the minimum pumping length can be M, or it can be M-1, or it can be M-2. Is this clear? See what I'm saying. This M is a pumping length. This M is a pumping length. So minimum pumping length, what that will be? So for L, we will have to find out. So for this language L, the minimum pumping length can be what it can be. Remember, the minimum pumping length we have to find out. The minimum pumping length can be M. Okay, remember, it can be M. It can be M plus M-1. We have to find out. It can be M-2. Okay. So remember, this we have to find out. It is depends on L. It depends on L. Is this point clear? Please tell me. Is this point clear? Let me know. See, this we have already seen. This proof we have already seen for this statement. Look at this statement that for any regular language, number of states in the minimal DFA, number of states in the minimal DFA is a pumping length. It is a pumping length. So the minimum pumping length, okay, this minimum pumping length, this can be M, this can be M minus 1, this can be M minus 2, and so on. This can be 1 also. This depends on L. It will depend on L. We have to find out. It will depend on L, so we have to find out. We have to analyze and we have to find out. Okay, so this is what I'm saying. That minimum pumping length will be less than or equal to M. Please tell me, is this point clear? Let me know. And remember, if M is pumping length, then every number greater than or equal to M, that is also a pumping length. This also you know. Okay, so this is the simple idea. I hope all these points are clear. Now tell me, so can I say that you have a regular language L? So this point we have already seen. Now, anyway, so this point you understood, right? This point, did you understand this point? Please tell me. For any regular language, you have a regular language, number of states in the minimal DFA, number of states in the minimal DFA, that is a pumping length. That is a pumping length. So minimum pumping length will be less than or equal to M. This point you understood. Okay, very good. Now let's move on. Tell me about this one. Yes, this also you understood, that if minimal DFA has M states, then minimum pumping length will be less than or equal to M. Okay, this point we understood. Now let's move on. What about this one? See, this is something interesting, that if your minimal DFA has dead state, if your minimal DFA has dead state, then what will happen? Okay, let's assume you have a language, assume for regular language L, there is a dead state in the DFA, in the minimal DFA. Okay, for regular language L, assume minimal DFA has dead state. Assume this minimal DFA has a dead state. Okay, is this clear? For regular language L, let's assume that minimal DFA has a dead state. Now, tell me one thing. Just remember the proof. I told you what is the proof. Yes or no? The proof of pumping lemma we have already seen. The proof of pumping lemma we have already seen. Now you tell me, for the candidate string, will they ever enter in the dead state? The candidate strings, will they ever enter in the dead state? Will they ever enter in the dead state? So from candidate string point of view, see, you already know that. Okay, assume that you have a dead state. Assume you have a dead state. Let's call this dead state, let's call it D. So you have a dead state D. Now you can easily notice that these strings, which strings? Strings in L. Okay, remember, if W belongs to L, then W can never enter into dead state. Yes or no? If W belongs to L, then DFA on M on W can never enter into dead state. Can never enter into dead state. Enter into dead state. Yes, correct. Agree? Okay, so very simple point I'm saying that for regular language L, if your minimal DFA has a dead state, if you have a dead state, if there is a dead state, then these strings which belong to L, these strings which belong to L, they will never enter into dead state. Agree? Agree or not? These strings which belong to L, they will never enter into dead state. Okay, so from these strings point of view, these are your candidate strings. So I can say, for candidate strings, this state does not matter. Yes or no? For candidate strings, what are the candidate strings? What are the candidate strings? Candidate strings are those strings which belong to L and whose length is greater than or equal to pumping length. Okay, so you can notice, for candidate strings, this dead state is not even there. Yes or no? They don't care about dead state. So from candidate string point of view, you can just assume there is no dead state. Okay, from candidate string point of view, point of view, from candidate string point of view, okay, we can just forget about dead state. We can just forget about dead state. Agree or not? Please tell me. Strings which belong to L, strings which belong to the language, from these strings point of view, we can just forget about dead state, because they will never enter into the dead state. Is this clear? So from candidate string point of view, they will never enter into the dead state. So we can just forget about the dead state. So finally, what I want to say, this is the result I want to say. I want to say this result. Okay, this is the result. The result is this, that for regular language L, you have a minimal DFA. You have a minimal DFA. And let's assume in this minimal DFA, you have total M states, but one of them is dead. But one of them is a dead state. Then tell me, what can you say? Then, okay, if this happens, then what I can say? If this happens, then P equal to M minus 1 will work. Yes or no? You can forget about the dead state. This will work. So I can say, what is the minimum pumping length? This is the pumping length. Remember, this is the pumping length. Okay, this is the pumping length. So what is the minimum pumping length? That will be less than or equal to M minus 1. So this point I just want to tell you. Simple point, right? Tell me, is this point complicated, or did you understand? For regular language L, if you have minimal DFA which has M states, if one of them is dead state, then from the candidate string point of view, from the proof point of view, you already remember the proof. This proof we have already seen. You already remember this. So from the proof point of view, from the candidate string point of view, this dead state does not matter. From the candidate string point of view, this is what I am saying. Strings which belong to L, they will never enter into dead state. These strings which belong to L, they will never enter into dead state. So these are your candidate strings. So from candidate string point of view, you can just forget about dead state. So finally, this is what I am saying, that minimum pumping length that will be less than or equal to M minus 1. This is your minimum pumping length. Okay, is this clear? So this is your another point we have already seen. So we have seen this point, we have seen that minimal DFA has M states, one of them is dead state. So this minimum pumping length that will be less than or equal to M minus 1. Okay, let's move on. This also we have seen. Finite language. For finite language, what will happen? For finite language, do you need to do some analysis? If you want to find minimum pumping length for finite language, will you do some analysis? No. For finite language L, the minimum pumping length that is equal to length of shortest length of shortest string plus 1. That is equal to length of shortest string plus 1. Length of longest string. Length of longest string plus 1. Okay, length of longest string plus 1. For finite language, you can see, for any finite language, if you have a finite language, then minimum pumping length, this will be length of longest string plus 1. That's it. So this is your for finite languages. Okay, let's move on now. So these are the results that we have seen. All these results. Okay, let's read them one by one. Okay, let's read them. This first result, are you comfortable with this result? This result, that minimum pumping length will be less than or equal to n, where n is the number of states in minimal DFA. This first statement is clear? Let me know. This first statement, is this clear? You can notice minimum pumping length. This will be less than or equal to n, where n is the number of states in minimal DFA. What about the second statement? The second statement is saying minimum pumping length, MPL. Okay, from now onwards, minimum pumping length. What I will call it? Minimum pumping length. I will call it MPL. Okay, this is what I will call it for short, for convenience. Okay, so let's see this. You can notice MPL will always be strictly greater than the length of smallest string. Yes or no? This MPL, this will be strictly greater than length of shortest string. Length of shortest string. Length of shortest string. Okay, so this is your second point. What is the third point? This we already know. Pumping length, that is greater than or equal to 1 by definition. It is by definition. The fourth point, if you have dead state, then this MPL, minimum pumping length, this will be less than or equal to n minus 1, where n is the number of states in DFA and you have dead state. And what about this statement? If you have a finite language, if your language is finite, then MPL will be x plus 1. MPL will be x plus 1, where x is the length of longest string. And the last point, if x is pumping length, then every number greater than equal to x is also a pumping length. So all these points, are they clear? All these 6 points, are they clear? So these are the 6 points you can easily notice. Okay, let's move on now. Now let's see how to prove L is non-regular. If someone asks you, prove L is non-regular, then what you will do? How to prove that L is non-regular? How to prove this? So we can prove this by contradiction. See, how to prove n is non-regular. We want to prove n is non-regular. Then what we can do? We can prove by contradiction. See, how will we prove? Notice, we can prove by contradiction. What I will do? I will assume L is regular. Okay, first I will assume L is regular. Remember, first I will assume L is regular. If L is regular, then by pumping lemma, what should happen? Assume L is regular. Remember, I am assuming L is regular. Now, if L is regular, then there must be a magical number. Yes or no? If L is regular, then L must have magical number. L must have, because L is regular. Every regular language must have magical number. So L must have a magical number. L must have a pumping length P, for which every candidate string pumps. Okay, for which every candidate string pumps. Now tell me, for any P, if I can prove, okay, for any P, arbitrary, remember, arbitrary P, I'm not taking a specific value. Don't take a specific value. Don't take P equal to 10, P equal to 20. Don't take a specific value. Some arbitrary value. Arbitrary, or I can say abstract. Okay, abstract. So for any P, if I can prove there is a violating string, if we can show there is a violating string, tell me, if we can show at least one violating string, then what I can say? Tell me. For any P, if we can show at least one violating string means that string which does not pump. Violating string means string which does not pump. So if we can show at least one violating string, then I can say pumping lemma not satisfied. Yes or no? Then I can say pumping lemma not satisfied. Then pumping lemma not satisfied. And because pumping lemma is not satisfied, so finally what I can say? Pumping lemma is not satisfied. So it simply means L is non-regular. Okay, my assumption was wrong. Yes or no? If pumping lemma is not satisfied, it means my assumption was wrong. it means my assumption was wrong. Okay, so remember, if pumping lemma is not satisfied, then our assumption was wrong. Then our assumption was wrong. Then our assumption was wrong. Okay, it means L is non-regular. So L non-regular. Okay, very simple. I hope this point is clear. So remember this point, a small point, you just understand that if I give you any language, so this is the template, this is what you need to do. Okay, to show L is non-regular, to show that L is non-regular, L is non-regular. If you want to prove this, if you want to prove L is non-regular, then remember what you need to do. Then take P. Okay, then what you will do? You will take P. Will you take specific value or will you take abstract value? You will take P, means abstract value. Arbitrary value you will take. Arbitrary value you will take. Don't take P equal to 20, P equal to 30. Okay, so take P. Then what you will do? Then second thing what you will do? Find at least one string. Find at least one candidate string. Find at least one candidate string. Okay, what you will do? You will find at least one candidate string. Find at least one candidate string W which does not pump. Okay, which does not pump. Which does not pump. Whatever you do, it does not pump. Okay, yes or no? Find at least one candidate string W which does not pump. If it happens, if you can find such string, if you can find such string which does not pump, then L is non-regular. Then L is non-regular. Then language L is non-regular. So this is your template. Is this clear? So you take P, then you find at least one string which does not pump. Okay, then you can say that L is non-regular. So this is your template. Okay, let's move on now. So everything about pumping lemma we have already seen. Now the another thing, what was the last thing? Okay, we are looking at the summary of pumping lemma. This is the last thing. This is the last point, that how many versions are there for pumping lemma? For pumping lemma, how many versions are there? There are 3 versions of pumping lemma. There are 3 definitions of pumping lemma. Okay, there are 3 versions of pumping lemma. So we have total 3 versions of pumping lemma, remember. So tell me, this is the by default version, yes or no? The pumping lemma that we use, this is the pumping lemma we will always use. This is by default pumping lemma. So I can say this is your version 1. I can say this is the version 1 of pumping lemma. And remember, this is the by default pumping lemma. So if someone asks you to apply pumping lemma, then this is the pumping lemma you will apply. And this pumping lemma we have seen. Okay, this is the by default. So remember, this is your by default version of pumping lemma. So you have to apply this pumping lemma. If someone asks you to apply the pumping lemma, then this is the by default pumping lemma. This is what you have to apply. Okay, but there is another version of pumping lemma. This is another version of pumping lemma we have already seen, if you remember, from the Peter Lin's book. This also we have seen, if you remember. Okay, so this is your version 2. This pumping lemma, this is version 2. Will you apply this? Will you apply this? No, don't apply this. But I'm just saying that if the question comes, if some MCQ, MSQ question comes, if this is given to you, then you can say that yes, this is also correct. Okay, so this is your version 2 of pumping lemma. And there is another version from the Stanford University. This is your version 3. This is your version 3 of pumping lemma. Okay, so these are the 3 versions. What are the difference? Tell me, what is the difference between all these versions? Let's see comparison of all these versions. Comparison. By chance, if the question comes, you can handle comparison of all versions of pumping lemma. All versions of pumping lemma. By chance, if some question comes in the GATE exam, then you can handle it. So let's do the comparison of all these versions. Okay, so let's see. The comparison is basically on the position of y. The difference is based on the position of y. Yes or no? What is the difference between all these versions? Tell me, what is the difference between all these versions? What is different in all these versions? Difference. What is the difference in all these versions? The only difference is in the position of y. Where is the position of y? This difference happens, okay, for position of y. For position of pumping part y. Okay, for position of pumping part y. Where this y will be. So you can see in the definition 1, in the definition 1, or I can say version 1, which is by default. Version 1, which is by default. There what we say? In the version 1, what we say? In version 1, we say that for any candidate string, for any w, see, in all the versions, this part is common. Okay, what is common in all the versions? Common part in all the versions. Common part in all versions. What is that? See, let's see the common part in all the versions. This is the common part. Okay, this is the common part that if L regular, then there exists a magical number. Okay, if L is regular, then there exists a magical number. There exists a pumping length P. Then there exists a pumping length P such that for all candidate string, for all W, okay, which for all W which have length greater than or equal to P and who belong to the language. Okay, so for all such W which belong to the language and whose length is greater than or equal to P, for all such W, W can be broken into 3 parts. Yes or no? For all such W can be broken into 3 parts. For all such W. For every such W can be broken into 3 parts. Now the difference will come. Now in the version 1, what will happen? In version 2, in version 3, what will happen? In the version 1, what will happen? In this version, it will happen that you have 3 parts. Okay. And in the version 1, in the by default version, we say that within the first P symbols, you have XY. Yes or no? In this version, we say that within the first P symbols, you can find this Y. Okay. Within the first P symbols, you can find this Y. And of course, Y is non-empty. And of course, you can repeat this Y any number of times. So this is your definition 1. This is your version 1. In version 2, what will happen? W can be broken into 3 parts. Remember. And in this version, what we say? We say Y can be found in the last P symbols. Yes or no? Y can be found in the last P symbols. This Y can be found in the last P symbols. Within last P symbols, you can find Y. This Y you can find in the last P symbols. And of course, Y is non-empty, and you can repeat this Y any number of times. The result will belong to L. Okay. Now you tell me in the version 3, what happens? In the version 3, what will happen? So this was for version 2. Okay, now tell me about version 3. In the version 3, what will happen? Y can be anywhere. Okay, W can be broken into XYZ. You can break this W into XYZ. And remember, this Y you can find in any P symbols. This Y can be, I can say, this Y can be found in any consecutive P symbols. Okay, I can say Y can be found. There is no restriction. On Y. You can find this Y in any consecutive P symbols. Okay, so remember this Y can be found in any consecutive P symbols. Within any consecutive P symbols. Okay. So there is no restriction on the position of Y. You can find this Y within any consecutive P symbols. So tell me, there is no restriction on the position of Y. So the only restriction is Y is non-empty. And also you can repeat this Y any number of times. So that's it. So basically, this is your version 3. There is no restriction on the position of y. No restriction on the position of y. This is your version 3. So tell me, did you understand? By chance, if some question they give you some MSQ question, can you handle it? Definition 1, definition 2, definition 3, like that. If they give you some question, can you handle it? Okay. So this is your complete summary. So that's it. Summary is over. The complete summary of pumping lemma is over. Please tell me. In this summary, we have revised everything that we have seen in the last 4 lectures. From part 1 to part 4, whatever we have seen, the complete revision we have done in this summary. Okay. Now let's do a lot of practice. Let's start with this question from Michael Sipser. You can see this is a question from Michael Sipser. This question number 1.55. And this is a very nice question. This is very popular question actually. This question from Michael Sipser, this is a very popular question. In many universities, they use this question. Okay, so let's solve this question completely. So first of all, tell me what this question is asking. The question is saying, the pumping lemma says that, okay, so everything is given. Read this question. The pumping lemma says that every regular language has a pumping length P such that every string in the language can be pumped if it has length P or more. Okay, yes or no? Read this. Everything we have seen, read this complete statement. Okay, so every regular language has a pumping length P such that every string in this language can be pumped if the length is greater than or equal to P. Next, if P is a pumping length, then every number greater than equal to P is also pumping length. This is also given, you can notice. If P is a pumping length, then every number greater than equal to P, that is also a pumping length. So you can find the minimum pumping length. Minimum pumping length, that is the smallest P, that is pumping length for this language. Okay. So very easily. Now you can see, for example, for this language, the minimum pumping length MPL, that is 2. Okay. Now the question is asking, for each of the following languages, give the minimum pumping length. This is what we need to find out. Okay. So let's start now. Let's start one by one. For every language, we have to find minimum pumping length for every language. So let's start with the part 1. Take your copy pen. Please take your copy pen. So this is your language 1. What is the language 1? That is 0001 star. This is your language 1. Okay. First you understand the language and then you find the minimum pumping length. First you understand the language. Your language is this: 000, then 0001, then 00011, then 000111, and so on. Okay. So tell me one thing. From where you will start? You want minimum pumping length. You want MPL, minimum pumping length. Okay. This is what you want. You want minimum pumping length. So let's call it MPL. So tell me from where you will start. If you remember, I told you this is the shortest string, correct? See, this is the shortest string. Yes or no? This is your shortest string. See, this is your shortest string. And because this is shortest string, has length 3. Shortest string has length 3. So what can I say? Minimum pumping length should be greater than or equal to 4. Or I can say it should be strictly greater than 3. Yes or no? Agree? Do you agree with me? In this language, the shortest string has length 3. This is the shortest string. So minimum pumping length should be strictly greater than 3. So from where I will start checking? From where I will start checking? I will start checking from 4 onwards. So let's check P equal to 4. Does it work? Does it work? Let's check. We have to check. P equal to 4. Will it work? Okay. So tell me, what are the candidate strings? If P equal to 4, then what are the candidate strings? If P equal to 4, you are checking P equal to 4. So what are the candidate strings? These are the candidate strings: 0001, 00011, 00011, and so on. These are the candidate strings. Okay. Can you guarantee all of them will pump? Can you guarantee? For example, if I give you a candidate string, there can be more ones. Okay, this is the general solution. I am giving you general solution. I am directly giving you general solution. I am giving you general solution directly. So tell me, will they pump? So let's see this. For example, okay, before the general solution, let's see whether you can pump this string or not. Let's see, can you pump this string? If I take W equal to 0, 0, 0, 1, if I take this string, in which area you will find Y? In which area you will find Y? In which area? In the first four symbols. So in this area you will find Y. Remember, these are the first P symbols. These are the first P symbols. So in this area you find Y. Okay, so we find Y here. So tell me which Y will work? Anyone? Which Y will work? Yes, you can take this Y. This Y works. You can take this Y. You can notice Y is non-empty. And you can notice you can repeat this Y any number of times. The result will belong to the language. So you can see for this string, this is your string. For this string, I am saying that this Y will work. So what is X? X is 000. This Y will work. Z is empty. So now you can easily notice X, Y power N, Z, that will belong to language for all N greater than equal to 0. Yes or no? So this Y will definitely work. This Y will definitely work. You can repeat this Y any number of times. The result will belong to the language. Okay, and similarly, you can do the general solution also. You can do the general solution. Whatever candidate string you take, whatever candidate string you take, tell me in which area you will find Y. You will find Y in this area. Okay, in this area you will find Y, because these are the first P symbols. These are the first P symbols. We are checking P equal to 4. We are checking P equal to 4. So these are the first P symbols. So you can easily notice this Y will work. Okay, this Y will work. So that's it. So I can say for this language, what is the minimum pumping length? Tell me. For this option A, for this language, this is your language 0, 0, 0, 1 star. For this language, the minimum pumping length, that will be 4. Quite easy. Okay, can I say? Quite easy. You can do this. Now tell me the next one. So this language we have done. Now tell me the second one. 0 star, 1 star. Let's see the second one. This is your language. 0 star, 1 star. What is the minimum pumping length? Take your copy pen. Take your copy pen. First, you understand this language. This language is like this. You have epsilon, you have 0, you have 1. Okay, you have 0, 1 also. You have 0, 0, you have 0, 0, and so on. You have 1, 1 also, you have 1, 1 also, and so on. You have 0, 0, 1, you have 0, 1, 1, and so on. Okay, so like this. Basically, any number of 0 followed by any number of 1s. Any number of 0 followed by any number of 1s. Okay, so tell me from where you will start. From where you will start. See, one thing you can notice. I can guarantee that. See, just make a DFA for this. Okay, let's make a DFA for this. Minimal DFA. Please make a minimal DFA for this. So what will be the minimal DFA? Any number of 0 come, I have no problem. 1 comes, I have no problem. Any number of 1s come, I have no problem. I have no problem. And after 1 if 0 comes, I will go to dead state. I will go to dead state. Yes or no? This is your minimal DFA. Now tell me, in the minimal DFA, how many states are there? In the minimal DFA, how many states are there? There are 3 states. But one of them is dead state. Yes or no? There are 3 states, but one of them is dead state. See, minimal DFA for L has 3 states. But one is dead state. But one of them is a dead state. So you tell me. Okay, tell me which range you have to check. One of them is dead state. Remember, minimal DFA has 3 states. But one of them is dead state. So I can simply say that you have to check. I can say minimum pumping length that will be less than or equal to 3 minus 1. And that will be greater than, strictly greater than length of shortest string plus 1. So I can say it will be like this. Okay, so this is the range you have to check. So minimum puppy length will be from 1 to 2. You only have to check 1, 2. Yes or no? Do you have to check p equal to 3? Will you check p equal to 3? No. Can you guarantee p equal to 3 will work? Can you guarantee p equal to 3 will work? P equal to 3 will work. Yes. For this language, you can notice for this language, minimal DFA has 3 states. Okay. One of them is steady state. So there is a guarantee. So for this language, I can say, can I say p equal to 4 is pumping length? Please tell me the answer. Can I say p equal to 4 is pumping length for this question? Can I say p equal to 4 is pumping length? Yes, of course. I'm not asking minimum. I am asking p equal to 4 is pumping length. Yes. Can I say p equal to 2 is pumping length? Can I say p equal to 2 is pumping length? That is also yes. Because 3 states you have, minimal DFA, and 1 state is dead state. So p equal to 2 is also pumping length. Okay, this is also pumping length. So we have to check p equal to 1 only. Do you agree with me? We only have to check p equal to 1. Okay, p equal to 1 we have to check. I hope this point is clear. Let me know. Is this point clear? Do you remember this result? That for regular language L, do you remember this result? That for regular language L, if minimal DFA has M states and one of them is dead state and one of them is dead and one of them is a dead state, then in this situation, what is the pumping length? Just tell me p. Just tell me pumping length. What is the pumping length? Then in this situation, m minus 1 is a pumping length. Yes or no? In this situation, m minus 1 is a pumping length. Okay. And what is the minimum pumping length? That will be less than equal to m minus 1. Okay. Minimum pumping length will be less than or equal to m minus 1. So these are the points we have already seen. Anyway, so let's check p equal to 1. We only have to check p equal to 1. Remember for this language, p equal to 2 works. We already know. P equal to 2 works. We already know. Don't have to check. We don't have to check. So just check p equal to 1. Just check p equal to 1 works or not. Okay. Yes or no? Just check p equal to 1 works or not. So tell me, will it work? P equal to 1. Checking p equal to 1. I am checking p equal to 1. Will it work? So what are the candidate strings? For example, this is a candidate string. It will pump. Yes or no? This candidate string will pump. Okay. I am telling you pump candidate string. You tell me what is the part Y. I am telling you candidate string. I am giving you candidate string. Okay, please understand. I am giving you candidate string W, and you tell me the pumping part Y. You tell me the pumping part Y. For example, if I give you this string, what the pumping part? What will be the pumping part? That will be 0 itself. Can you repeat this 0 any number of times? Can you repeat this 0 any number of times? Yes, if you repeat it any number of times, the result will belong to the language. If I repeat it 0 times, what I will get? If I repeat it 0 times, I will get empty string, belongs to the language. If I repeat it 3 times, belong to the language. Okay. For this, the pumping part will be 1. Okay. What about for this one? What about for this one? What is the pumping part? Pumping part will be 0. Okay. Pumping part will be 0. I hope all these points are clear. For this, what will be the pumping part? For this string, the pumping part will be 1. The pumping part will be 1. And what about for this string? What about for this string? What about for this string? This is not even a candidate string. This is not even a candidate string. Okay, this is invalid. This is I can say not a candidate string. So you don't have to worry about it. So you don't have to check it. This is not a candidate string. So I can say this is like invalid, or I can say just simply say nonsense. Okay, you can just simply say nonsense. Just say nonsense and move on. Okay, clear? Remember, this is not a candidate string. This is not a candidate string. So can I say p equal to 1 is working? Yes. See, remember p equal to 1 works. Okay, whatever candidate string you take, any candidate string you take, whatever candidate string you take, the first symbol you can take as y. Yes or no? The first symbol you can take as y. This first symbol. This is the first symbol. Okay, this first symbol you can take as y. Is this clear? Let me know. So p equal to 1 will work. Whatever string you take, whatever candidate string you take, this first symbol you can take as y. So if p equal to 1 is working, what the minimum pumping length then? The minimum pumping length, that will be 1. Okay, that will be 1. So tell me, can I say minimum pumping length that is equal to number of states in minimal DFA? Is this statement correct? Is this statement correct? That minimum pumping length, see, I am asking these two statements I am asking. Can I say minimum pumping length is equal to number of states in minimal DFA? In minimal DFA? And second point, can I say pumping length is equal to number of states in minimal DFA? Which statement is correct? Which statement is correct? So I can say this statement is wrong, this statement is correct. Okay, let's move on now. So we have seen the second language. What about the third language? The third language, that is 0, 0, 1 union 0 star 1 star. Okay, so your third language, that is 0, 0, 1 union 0 star 1 star. 0 star 1 star. Okay, here something interesting I want to tell you. Here's something interesting I want to tell you. Tell me one thing. Tell me one thing you tell me. For this pumping length, will it depend on the language or will it depend on the small parts of the language? Tell me. This pumping length, when you are finding P, okay, to find P, will you look at the complete language or will you look at small parts? Tell me. Will you look at complete language? Yes, you will look at complete language. Yes or no? To find P, focus on language. Focus on language. See, very big I am writing because I know you will make mistake. I already know you will make mistake. That is the reason I am writing in very big letters. To find P, focus on complete language. Complete language. Not on parts of it. Not on parts of it. I don't care about parts. I only care about the complete language. Okay. Focus on the complete language. Don't focus on the parts of it. Is this clear? Because we only care about language. Remember, when I say x, y power n, z, then did I say belongs to some part or did I say it belongs to the language? When I say x, y power n, z, it belongs to the language. Okay, it belongs to the language. Remember, it belongs to the language. It should belong to the language. Okay, remember this point. So focus on the complete language. So don't focus on this. Don't focus on this. For example, if some student is doing like this, for example, for this part, okay, forget about the remaining. For this part, if I want to ask you what is the pumping length, for this part, forget about the remaining language. For this part, the answer will be 4. Okay. And for this part, the answer will be 1. So can I say final answer will be 1 or final answer will be 4? Can I say like this? These statements, can I say that final answer will be minimum of these or maximum of these? Okay, minimum of these or maximum of these. All these things are nonsense. Okay, all these things, final answer is minimum of these, maximum of these, average of these. Okay, median of these, falana these. So remember, these things are, what you will say, nonsense. Okay, so these things are nonsense. Don't focus on parts. Again, I'm telling you, don't find that, okay, focus on this part, then find minimum or find maximum. Everything is nonsense. Everything is nonsense. Is this clear? This is a big nonsense. Please tell me, because you have to focus on the language. You have to focus on the language, not on the parts of it. So tell me, what is the language? Just tell me the language. What is the language? Your language is this. In your language, you have 0, 0, 1. You have empty string also. You have 0 also. You have double 0 also. You have triple 0 also. You have 1 also. You have double 1 also. Triple 1 also. Okay. You have 0, 1 also. You have 0, 0, 1. You have 0, 1, 1. And so on. Okay. So these things you have in the language. So remember, your language is this. Actually, this is covered in 0 star 1 star. Yes or no? Actually, this language is 0 star 1 star only, because this is actually covered in this 0 star 1 star. Okay. So actually your language is 0 star 1 star. Your language is 0 star 1 star. And for this language, we have already found the pumping length. What is the minimum pumping length? What is the minimum pumping length? That will be 1. This we have already found. So remember, this language, this 0, 0, 1 is already included in this. This 0, 0, 1, this is already included in this 0 star 1 star. This is already included. Okay. So your language is basically this. So final answer will be 1 only. Okay. What about the next one? What about the next question? What about this one? So let's solve it. D part, 0 star 1 plus 0 plus 1 star. So this D, what this is saying? It is saying 0 star L is equal to 0 star 1 plus 0 plus 1 star, 0 plus 1 star, and then 1 0 star 1 union 1 0 star 1. Okay. What about this one? 1 0 star 1. First you tell me, can I say every string that you can create here, you can also create here? Can you do that? Can I do that? Every string that I can create here, can I also create there? For example, here I can create 1 1. I cannot create 1 1 here. Okay, I cannot create 1 1 here. Here I can create 1 1, but I cannot create 1 1 here. What about the remaining? Can I create 1 0 1 here? Here can I create 1 0 1? Yes, I can create 1 0 1. I can create 1 0 0 1. I can create 1 triple 0 1. So did you notice only 1 1 is new here? So this language is same as what? Tell me, this language is same as what? 0 star 1 plus 0 plus 1 star union. Only this string is new. Only this string is new. Okay. From this, you can only create this new string. Every other string is already covered here. Every other string that already belongs to the first part. Okay. Anyway, this is your entire language. So first you understand the language and then you solve the question. So in this language, what are the strings you have? So for example, you have 1 1. What other string you have? For example, you have 1 0 also. Okay. And so on, some strings, some more strings you have. For example, 1 0. Is there any other two length string? Is there any other 2 length string? No. How many 3 length strings you have? How many 3 length strings you can create? 3 length strings. Either you can create like this, or you can create like this, or you can create like this, or you can create like this. Only these are the 3 length strings. Yes or no? Is this clear? You can check how many 3 length strings are there. Only these are the 3 length strings, and so on. So this is your language. So first you understand the language. Now, after understanding the language, you tell me from where you will start checking this pumping length you want, minimum pumping length. So from where you will start checking, you can notice this is the smallest string. You can notice this is the shortest string. This is the shortest string. So minimum pumping length, that will be strictly greater than 2. That will be strictly greater than 2. Okay. Yes or no? So here I can easily say that it will be strictly greater than 2. So let's start with 3. Tell me about 3. Will it work? Your language, remember, your language was 1 1. then you have 1 0, then you have 1 0 1, 0 1 0, 1 1 0, 1 0 0, and so on. Basically your language is 0 star 1 plus 0 plus 1 star union 1 1. Okay, basically this is your language. So tell me, will it work? P equal to 3, will it work? Let's check. Let me check, will it work or not? P equal to 3. Will it work? Let me know. First, can you create DFA for this? For this language, what will be the DFA? For this language, I think if you create the DFA, it will take some time. Okay, so let's directly check the P equal to 3. See, what you can try, you can create DFA, minimal DFA. This I give you as a homework. Okay, you can try this. But anyway, let's directly do this. So P equal to 3, will it work? So what are the candidate strings? Tell me, what are the candidate strings? So this is not even a candidate string. Yes or no? This 1 1. So tell me, I am giving you candidate string and you tell me what is the part Y? What is the part Y? For example, if I give you this candidate string 101, which part Y you will take? For this string 101, you can take this part Y. Okay, you can take this part Y. So basically this will work as Y. What about the next string? For example, 010, which part you can take as Y? Remember, in this 101, you can take this 1 equal to Y. You can take this equal to Y. You can repeat it any number of times, no problem. You can repeat it any number of times, no problem. Okay. Next, what about this one? 010. 010. What about this one? 010. So for this, I can take this 0 as Y. I can take this 0 as Y. Okay, this 0, remember? Because 010, I can repeat this 0 any number of times, no problem. It will create no problem. What about the next? 110. Is there any Y in this 110? 110. 110. Tell me. In this 110, I can take this as Y. I can take this as Y. Okay, this you can pump. What about the next string? What about the next string? That is 100. 100. What about this string? Here you can take this as Y. Okay, so it looks like P equal to 3 will work. But can you guarantee? Can you guarantee P equal to 3 will work? Can you guarantee P equal to 3 will work? Tell me. Is there a guarantee that P equal to 3 will work? Tell me this. Can you guarantee that P equal to 3 will work? Yes, you can guarantee actually. See, you can guarantee because look at this. Your language 0 star 1 plus 0 plus 1 star. See, whatever string you take in this, whatever 4 length string, 3 length strings we have already checked. All the 3 length strings are already done. These are all 3 length strings. Okay, all the 3 length strings are already over. Now, what you can do? You can check if you take any 4 length string, then in that 4 length string, see, okay, see something interesting. What I am saying, you take any 4 length string. This is your W whose length is greater than equal to 1. Whose length is greater than equal to 4. You take a 4 length string. Now, if you use anything from it, please tell me, if you use anything from it, for example, from here, if you use at least 1 0, then your work is over. Agree? Agree or not? From here, if you use at least 1 0, from this part, please focus. From this part, if you use at least 1 0, I don't care about the remaining. If you use at least 1 0, then what I can do, tell me? Then this 0 I can use as Y. Okay, yes or no? This 0 I can use as Y. Is this point clear? From this, if I take at least 1 0, from this part, if I take at least 1 0, then this 0 I can take as Y. Tell me why? Because I can repeat it any number of times, no problem. Because I can repeat it any number of times. 0 star, this is 0 star. I can repeat it any number of times, no problem. Please tell me, did you understand? I am giving you general solution. Please tell me, did you understand? From here, if you take at least 1 0 from here, if you take at least 1 0, then the first 0 you can take as y. This first 0 you can take as y. This first 0 you can take as y. So what is the other case possible? We have covered all the cases where from here you are taking at least 1 0. Now, what are the remaining cases possible? Tell me. In the remaining cases, this part you are not taking. Okay, you are not taking this part. Yes or no? You are not taking this part. So you are starting with 1. You are starting with 1. And remember, this is again. Now you tell me, if I take at least 2 1s from here, if I take at least 2 1s from here, then also my work is done. If I take from here, if I take at least 2 1, if I take at least 2 1, my work is done. Yes or no? My work is done. If I take at least 2 1, then my work is done. I can take this as y. Is this point clear? So this case is also over. See, general solution is interesting, right? One by one, step by step, we are going. Are you understanding what I'm saying? The general solution, are you getting? So what is the other case? From here, I take only 1 1. That is mandatory. That is mandatory. From here, I only take 1. I only take 1 1. Now, from here, if I take 2 0, if I take 2 0, then also my work is done. If I take 2 0, please understand. If I take 2 0, if I take 2 0, then also my work is done. What I can do? I can take this 0. I can take this 0 as a y. This will also work. Is this point clear? Please tell me. Okay. I hope you are finding this solution interesting. The general solution. So what are the remaining case then? What are the remaining case? Don't take anything from here. From here, you only take 1 symbol. From here, you only take 1 symbol. Now, okay, now remember, we are considering those strings whose length is greater than equal to 4. We are considering those strings. So definitely from here, how many ones I have to take? I have to take at least 2 ones. I have to take at least 2 ones. Okay, now also my work is done. Now also my work is done. I can take this as y. Now, did we cover all the cases or not? We have covered every case. So this is your general solution. So we have covered every case. Please tell me, did you understand? Very nice question. This union 1 1, this union 1 1, for this language, minimum pumping length, that is 3. The general solution we have seen. The general solution we have seen. Okay, is this point clear? Please tell me. We have proven it. The proof we have seen. The general solution we have seen. From this general solution, you can get some idea. Okay, in the future also, you can do this type of general solution, right? See, one by one, we were going. If you take at least 1 symbol from here, then we can choose y. So don't take any symbol from here. From here, if you take 2 symbols, then also you can choose y. So from here, you take only 1 symbol. So something like this. Like this, you can find the general solution. Okay. I hope you understood. Hemant is asking, sir, small doubt. Is it necessary to check all the strings of length 3? See, is it necessary? Because those are candidate strings. Okay, just for understanding, we are checking so that we don't make a mistake. Hemant, see, the general solution is very good. You should understand the general solution. But remember, sometimes we can make mistake in the general solution, right? That is the reason. There is no problem. You can take some small cases and you can check it out. Yes or no? Is this clear? See, if you directly go to the general solution, okay, directly without checking anything, if you directly go to the general solution, then it is possible you can make mistake. There is a possibility of mistake. That is the reason. First you become comfortable with the language. This is what I'm saying. First you become comfortable with the language and then you do. For example, what I did you notice what I did? I checked 3 length strings manually, and then I checked all the strings in the general solution. Yes or no? Okay, agree? 3 length strings I checked manually so that I can become comfortable with the language. Okay, then all the remaining strings I checked in the general solution. So this is what I have done. Okay, let's move on now. Tell me the next language. So these things we have done, part A to part D. Now tell me about the next one, 0, 1 whole star. This is quite easy. This will not take too much time. Your language is 0, 1 whole star. First of all, you can notice what is the DFA. If you notice, if you create the DFA, what will be the DFA for this? The DFA will be like this. Initial state will be final because you want to accept empty string. Now, what you will do? 0 go here, 1 come back here. Okay, that's it. 0 go here, 1 come back here. And in this state, if 1 comes, then go to dead state. And after 0, if 0 comes, go to dead state. Okay, this is your DFA. So from this DFA, can you notice? Did you notice that minimal DFA has 3 states? Minimal DFA, 3 states. One of them dead. One of them dead. One of them dead. So tell me, what can you say? One of them is dead. So what you can say, tell me. So I can say P equal to 3 minus 1 will work. Yes or no? This will definitely work. Agree? P equal to 2 will definitely work. But what about minimum pumping length? That will be less than or equal to 2. That will be less than or equal to 2. So P equal to 2 will definitely work. Okay, remember, P equal to 2 will definitely work. So what we have to check, tell me. P equal to 1 is already working. For this, P equal to works. P equal to 2 works, already works. So tell me, you have to check P equal to 1 only, right? Okay, will it work? P equal to 1. It will not work. It will not work. Okay, why it will not work? What is the violating string? P equal to 1 will not work. For example, consider this string. For example, consider this string. This is a candidate string. You can notice this is a candidate string. So take this string. In this string, what will happen? This is the only possibility for Y. In which area you will find Y? Tell me. Tell me in which area you will find Y. You will find Y in this area. In the first one symbol. In this area, you will find Y. Okay, so if I take Y equal to 0, then where is the problem? Then where is the problem? If I take Y equal to 0, then where is the problem? The problem is xy power 0 z, that is equal to 1. That does not belong to the language. Okay, clear? So I can say P equal to 1 does not work. So what is the answer for this? L equal to 0, 1 whole star. What is the minimum pumping length? MPL. Minimum pumping length. That will be 2. Okay, that will be 2. Now let's move on. What about the next one? Is this language? First of all, you tell me, is this a language? Is this a language? Is this a language? Is this a language or a string or what is this? Is this a language or a string or what is this? If this is a string, can I ask you pumping length for it? Pumping length is defined for language or string. Please tell me. This pumping length, it is defined for language. This pumping length is defined for what? Please tell me. It is defined for what? Is it defined for language or is it defined for string? Tell me. Is it defined for language? Yes, it is defined for language. It is not defined for string. So can I say it is string? So can I say Michael Sipser is mad? For string, he is asking pumping length. Can I say? Can I say? For string, he is asking pumping length. Is there any wrong? Array, this is not a string. This is regular expression. This is regular expression. This is not a string. This is regular expression. Is this clear? See, this is regular expression. This is regular expression. See, this is regular expression. Regular expressions are given. This is not a string. Is this point clear? This is not a string. Let me know, is this point clear? Please tell me. So in this part F, a string is not given. This is given and this is not string. This is not string. This is regular expression. So what is the language of this? Tell me. What is the language of f? What is the language of this f? That is set containing empty string. What is the language of this regular expression? If your regular expression is this, then what will be the language? Tell me. If your regular expression is this, then language will be what? If your regular expression is this, then language will be this. Okay. If your regular expression is this, then language will be this. I hope all these points are clear. So remember, language is this. And for this language, we have to find pumping length. For this language, we have to find pumping length. Clear? First of all, you tell me, is this clear? So anyway, this is your language. Your language is finite or not? This is a finite language. This is a finite language. So what will be the minimum pumping length? So minimum pumping length, that will be length of longest string. Length of longest string. Okay, so you find the longest string in this L. Longest string in L. Length of that plus 1. Length of that plus 1. So answer will be 0 plus 1. That will be 1. So for this question, answer will be 1. Minimum pumping length, MPL, will be 1. Simple. Okay. What about the next one? What about this one? Can I give you as a homework? Can I give you as a homework? Please tell me. Can I give you as a homework? Okay. These remaining questions. Okay. So you take as a homework. Okay. This next part also, please take as a homework. Where you will find the solution? Where you will find the solution? You can find the solution on GATEOverflow website. I have already written the solution of this question. Okay. For this question, I have already written the solution. For this question, I have already written the solution for every part. So you can find the answer on the GATEOverflow website. Okay. The answer, where you can find answer? Answered on GATEOverflow. I will put the link in the comments. This video I will upload on the GoClasses YouTube channel, and in the description, I will put this link. Okay. On the GATEOverflow website, this answer. So basically, I can say link in description. Okay. I will put the link in the description. Okay. Now you tell me about this one. This is a regular expression, right? This regular expression is given to you. So what is the language? Remember, this is regular expression. Remember, this is not a string. Remember, this is not a string. This is a regular expression. So what is your language? Your language is this. So for this, what is the minimum pumping length? That will be length of longest string. Length of longest string plus 1. So the answer will be 5. Okay. What about this one? What about this one? Sigma star. For sigma star, the last one, J. This is your sigma star. This is quite simple. Just make a DFA. This is your DFA. In the minimal DFA, how many states will be there? Tell me. In the minimal DFA, how many states will be there? One state. Minimal DFA has one state. Minimal DFA has one state. So what will be the minimum pumping length? So for this minimum pumping length, that will be less than equal to 1. And because you already know it is always greater than 1. You know P is always greater than equal to 1. P is already, so I can say minimum pumping length will be 1. Okay, is this clear? Minimum pumping length will be 1. So I hope all these points are clear. Please tell me. Anyone has any doubt? Anyone has any doubt in this? Any doubt? Sri is asking, sir, in part B, had it been 10 instead of 001, then minimum pumping length. Part C. Okay. So you can take it as a variation in the part C. Just take it as a variation. So let's do the part C variation. Okay. A variation of part C. a variation in part C. Okay, let's do this. So you tell me, this is the variation that 0 star 1 star union 1 0 union 1 0. Okay, is this you are asking? Yes. Okay, so this is your language. Now you tell me what is the minimum pumping length. Now tell me what is the minimum pumping length. So first you understand the language. In this language you have 1 0, you have empty string, you have 0, you have 1, okay, you have 0 1, you have 0 0 1, you have 0 0, you have 1 1, and so on and so on. Okay, so tell me, first of all, in this, which pumping length will work? Tell me, which pumping length will work? Will P equal to 1 work? Will P equal to 1 work? Please tell me. Can I say P equal to 1? Will it work? Check it. Will it work? Okay, so let's start with 1 0. Will it work for this? For this string, will it work? For this string, will it work for 1 0? If I take this string, then what y you will take? Then what y you will take? In this area, you will find y. In this area, you will find y. So what y you will take? You can take y equal to 1. Okay, if I take y equal to 1, is there a problem? If I take y equal to 1, if I take this y, then there is a problem. Yes, there is a problem. Yes, there is a problem. There is a problem. There is a problem. What is the problem? Problem is when you repeat it, when you repeat this y 2 times, problem will happen when you repeat this y 2 times. When you repeat this y 2 times, this does not belong to the language. So there is a problem. So P equal to 1 does not work. Yes or no? Is this clear? P equal to 1 does not work. What about P equal to 2? What about P equal to 2? Will it work? P equal to 2, will it work? Again you take this string, which y will work? Okay, in this area you will find y. In this area you will find y. What are the possibilities for y? What are the possibilities for y? If you take y equal to 1, there is a problem. If you take y equal to 1, there is a problem. What is the problem? If you take y equal to 1, there is a problem. If you take y equal to 1. If you take y equal to 0, there is a problem. If you take y equal to 1 0, there is a problem. In every situation, there is a problem. Whatever y you take, there is a problem. Where is the problem? Just repeat y 2 times, you will see the problem. Just repeat y 2 times. Repeat y 2 times, you will see the problem. Just repeat this y 2 times, you will see the problem. Is this clear? Please tell me. So P equal to 2 also does not work. So what is working for this language? 0 star, 1 star, union 1 0. For this, you can notice P equal to 3 will work. P equal to 3 will work. Because when you take P equal to 3, this will not even be a candidate string. This P equal to 3 will work. Okay, this P equal to 3, you can notice. This will work. Okay, because what are the candidate string now? Now what are the candidate string? Now the candidate strings, they only come from this. Okay, so they only will be like this. This type of candidate strings you will have. You will have this type of candidate strings. Something like this. Okay, and so on. So you can check P equal to 3 will work. So whatever candidate string you take, which symbol you will take as Y? Whatever candidate string you take, which symbol you will take as Y? You can just take first symbol as Y. This first symbol as Y, you can take, this will work. Okay, this first symbol you can take as Y. This will work. Not any of them. Not any of them. Because your Y must be in this area. In this area, you will find Y. In this area, you will find Y. Okay, so the first symbol you can take as Y. That will work. That will work. Okay, so very simple. This, I can say, this first symbol. You can take it as Y, it will work. I hope all these points are clear. So this question, this Michael Sipser question we have done. Please tell me, can you do this? Only these 2 questions I am giving you as a homework. Only these 2 questions I am giving you as a homework. Can you do this? Please tell me. Try this. The answer you can find in the description. Okay. The answer. I have already answered this question on the GATEOverflow website. The link you can find in the description. Okay. So do this. Remember, this is a very famous question. Let me tell you. This Michael Sipser question, this is very famous question. In every university, you will find this question. Every university, foreign university, Indian university, every university, they will give you this question in the assignment. This question will be given to you in the assignment. So in the future, if some question comes, then it is possible that they can give you one of these. It is possible. In the GATE exam, if some question comes, then it is possible they can give you one of these. Let's move on now. This is your GATE exam question. Sorry, UGC NET exam question. This is your UGC NET 2006 question. Tell me the answer. What is the answer for this question? The logic of pumping lemma is good example of pigeonhole principle. Okay. The proof of pumping lemma. In the proof of pumping lemma, we use the concept of pigeonhole principle, right? This proof we have already seen. The proof of pumping lemma we have already seen. Now, this same question has come in UGC NET 2017 also. The same question. See, this UGC NET question 2006 question. The same question came in UGC NET 2017 question. Here also pigeonhole principle. The logic of pumping lemma. The proof of pumping lemma. Okay. So that is a good example of pigeonhole principle. This we have already seen. This proof you can find in the part 4. Yes or no? In the part 4, we have seen this proof. This proof we have already seen. Now let's see this. The same question came in NILIT 2017. The same question. This came in NILIT exam also, the part A. That is the reason these exams are not good. They will duplicate the question. See, this type of thing will never happen in the GATE exam. In the GATE exam, they will never do this. In the GATE exam. Okay. The GATE exam will have 65 nice questions. 65 new questions will be there. Okay. So anyway, let's move on now. Now this is your GATE exam. This is the GATE 2019 question. GATE 2019 question. Okay. Let's see this. For alphabet sigma a comma b, this is the alphabet. Let us consider the regular language. This regular language is already given to you. Already it is given to you regular language. Which of the following can be a pumping length? Which of the following can be a pumping length? The question is asking pumping length or minimum pumping length. Tell me. The question is asking pumping length or is it asking minimum pumping length? Okay, which of the following can be a pumping length? The constant guaranteed by the pumping lemma for L. So you tell me one thing. Okay, let's not solve this question. Without solving the question, just think about it. Tell me, if P is pumping length, if P is a pumping length, then can I say every number greater than equal to P, every number greater than equal to P is also pumping length? Yes or no? Is also pumping length. Agree? If P is pumping length, then every number greater than equal to P, that is also pumping length. So you tell me, if the answer is this, remember this question is MCQ question. So only one option is correct. Only one option is correct. So tell me, if answer is this, then all of them will be the answer. Yes or no? Yes or no? If answer is this, then these will be the answer. If answer is this, then this also will be the answer. So if this is a MCQ question, then I can guarantee that this definitely will be the answer. I can guarantee that this will definitely be the answer, because remember, if this is the answer, then this also will be the answer. If this is the answer, then this and this also will be the answer. So for this question, option D is the answer. Like this, you can solve and get 2 marks. Just think about it. Okay, I want to ask you one thing. In 2024, if this type of question comes and they ask you pumping length, and let's assume MCQ question comes, then tell me what you can do. The question is asking me, pumping length, not the minimum pumping length. Then you can just select the maximum number. Yes or no? You can just select the maximum number. and you can get 2 marks. Oh, sorry, this is 1 mark. Okay, this is 1 mark. So you can get 1 mark. Without solving the question, you can get 1 mark. Is this clear? Without solving the question, you can get 1 mark. Anyway, interesting thing what will be? What will be the interesting thing now? Tell me. See, interesting thing will be minimum pumping length. Yes or no? If I ask you minimum pumping length, that will be the interesting thing. So let's make this question interesting and let's find minimum pumping length. Okay, take your copy pen. Take your copy pen and let's find minimum pumping length. Minimum pumping length. Let's do this. Okay, so let's find it. So your language is this. What is the language? In the language you have a power. In the language you have x, where either x is equal to a power 2 plus 3k or x is equal to b power 10 plus 12k. Okay, where k is greater than or equal to 0. This is your k. So first you understand the language. What is the language? Tell me. If you take k equal to 0, then in this language you have this type of strings. For example, if you take k equal to 0, then you can get a power 2. If you take k equal to 1, you can get a power 5. If you take k equal to 2, then you can get 8 power 11, 8 power 14, 8 power 17, and so on. Yes or no? What else you have? You also have b power 10 plus 12k. If I put k equal to 0, then I will get b power 10. If I put k equal to 1, I will get 22. If I put k equal to 2, then I will get 34 and so on. Is this clear? Tell me. So this is your language. So first you understand the language. The language is this: a power 2, a power 5. There is a gap of 3. A power 8, a power 11, and so on. A power 14. Also you have b power 10, b power 22, b power 34, and so on. This is your language. Okay. Now tell me, a lot of hit and trial we have to do. Yes or no? A lot of hit and trial we have to do. So tell me, first of all, from where you will start? First of all, tell me the starting point. You know, this is the shortest string. You know, this is the shortest string. You know, this is the shortest string. Shortest string has length 2. This is the shortest string in L. In this language, this is the shortest string. And this has length 2. So tell me, from where you will start? So I can say minimum pumping length. That will be strictly greater than 2. That will be strictly greater than 2. So you will start from 3 onwards. Okay, let me check for 3 quickly. Will 3 work? Let me check 3 quickly. Now you are expert of pumping lemma. Now you are expert of pumping lemma. So tell me, which string will violate? If I take p equal to 3, you can just directly see this string will violate. Take this string. Take this string will violate. Okay, take this string, this will violate. Okay, before I take this string, you tell me one thing. If I take p equal to 3, will I check this string? Will I check this string? This is not even a candidate string. This is not even a candidate string. This does not belong to the language. I don't care about this string. This string is nonsense. Yes or no? This is not even a candidate string. This string does not even belong to the language. So don't check this string. Don't check this string. For p equal to 3, what are the candidate strings? Tell me. For p equal to 3, who are the candidate strings? For p equal to 3. These are the candidate strings. Yes or no? For p equal to 3, these are the candidate strings. You only have to check these strings. These are the candidate strings for p equal to 3. If you check p equal to 3, now you tell me, will this string pump? If I take this string, will this string pump? Tell me, will it pump? Will this string pump? for p equal to 3, will this string pump? Tell me, will this string pump? Yes, this string will pump. This string will pump within the first, where you will find y. This is your w. You will find in this, you will find y in first three symbols. In first three symbols. In these first three symbols, you will find y. Yes or no? You will find y here. In this area, you will find y. Now you tell me which y you can take. You can take y equal to 3a. This y equal to 3a works. This y equal to 3a works. Now you tell me, if this string is pumping for p equal to 3, this string is pumping. So can I say p equal to 3 will work for L? For this language, p equal to 3 will work. For p equal to 3, this string is pumping. This string is pumping. So can I say for this language, p equal to 3 will work? No. You have to check all the candidate strings. For p equal to 3, every candidate string must pump. Every string must pump. Every candidate string. These strings must pump. Are they pumping? For p equal to 3, just check it out. This string will not pump. Just check it out. Look at this string, b power 10. Look at this string. Will it pump? Tell me, will it pump? Will it pump? For p equal to 3, will it pump? In this area, you will find y. You will find y in this area. These are the first three symbols. These are the first three symbols. These are the first p symbols. In the first p symbols, you will find y. Okay, so tell me, in this, now whatever y you take, if you repeat it 0 times, in the resulting string, how many b's will be there? Please tell me. Whatever y you take, for example, if I take y equal to b, I repeat 0 times. I repeat 0 times. Then the resulting string will be what? Tell me. If I take y equal to b, if I take y equal to this, then in the resulting string will be b power 9. B power 9, and that does not belong to the language. The resulting string will be b power 9, and that does not belong to the language. If I take y equal to bb, now again, if I repeat 0 times, then I will get b power 8. That also does not belong to the language. If I take y equal to triple b, and I repeat 0 times, then the resulting string will be b power 7. That also does not belong to the language. Did you notice? Whatever y I take, and if I repeat it 0 times, then resulting string will have less than 10 b's. Okay, is this point clear? See what I'm saying. In this string, your string w equal to b power 10. This is your string b, something like this. Now, in this, whatever y you take, remember here whatever y you take, if you repeat it 0 times, okay, in this area, remember, in this area, whatever y you take, in this area. Now, you tell me, whatever y I take, if I repeat it 0 times, then resulting string will have less than 10 b's. Yes or no? Agree? Do you agree with me? The resulting string has less than 10 b's. So it does not belong to the language. Yes or no? So it does not belong to the language. Whatever y you take, you can take whatever y you want. So can I say this p equal to 3 will not work? So for this language, p equal to 3 does not work. Agree? Do you agree with me that p equal to 3 will not work? And who will violate? Because this will violate. Okay, this will violate p equal to 3. This will violate p equal to 3. It will violate p equal to 3. Okay, now can you make one observation that which p it will also violate, which other p it will also violate? Now just make an observation. It will violate every p less than equal to 10. It will violate, remember, it will violate every p. It will violate every p less than equal to 10. Agree? Yes or no? It will violate every p less than equal to 10. This one person, this b equal to 10, this b power 10, b power 10. This will violate every p less than equal to 10. Agree? Do you agree with me? Yes or no? Please tell me. This will violate every p which is less than equal to 10. Why? Tell me why. For example, if you take p equal to 10, for example, if you take p equal to 10, then this is a candidate string or not? If you take y equal to, if you take p equal to 10, then this is a candidate string. Okay, then you can note this is a candidate string. This is a candidate string. Now this candidate string, okay, this is your b, 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 b. Now tell me, whatever y you take, if you repeat it 0 times, what will happen? Again here, whatever y you take, in this area you will find y. In this area, these are the first p symbols. These are the first p symbols. Okay, in these first p symbols, you will find y. You will find y in these p symbols. So you tell me, now tell me, whatever y I take, what will happen? Whatever y, what will happen? Tell me, whatever y I take, if I repeat 0 times, please tell me, whatever y I take, if I repeat 0 times, the result will not belong to the language. Agree? In this, whatever y I take, for example, if I take y equal to triple b, if I take y equal to this, y equal to 4b, and I repeat 0 times, what will be the result? If I take y equal to 4b, if I take this y, and I repeat it 0 times, I repeat this 0 times, what will be the resulting string? The resulting string will be b power 6. B power 6 does not belong to the language. B power 6 does not belong to the language. So remember, whatever y I take, if I repeat 0 times, the result will not belong to the language. The result will not belong to the language. So what you can say? I can say that p less than equal to 10 will not work. Agree? P less than equal to 10 not work. It will not work. Okay. Who is the violating string? Who is the violating string? The violating string, you can take p equal to 10. The violating string, you can take b equal to 10, b power 10. You can take this violating string, b power 10. Okay. So which p we have to check? Then tell me, which p we have to check? Okay, let's check p equal to 11. Let's check this. P equal to 11. P equal to 11. Now you tell me, for p equal to 11, what are the candidate strings? Let's check p equal to 11. What are the candidate strings? So now these are the candidate strings. These strings and these strings. These are the candidate strings now. Okay, only these strings are candidate strings. Correct? We only care about these strings. So tell me, which of these strings will not pump? If I take p equal to 11, will this string pump a power 11? If I take w equal to a, if I take this a power 11, will this pump this a power 11? Will this pump? Will it pump? Yes, this will pump. You can take this as y. You can take this as y, it will pump, no problem. Yes or no? You can take this as y, y equal to triple a, it will pump. Okay, so this will pump. This will definitely pump, there is no problem. This will pump. I have no problem with this. Okay, so for p equal to 11, these will pump. Yes or no? Actually, all of them will pump. These strings will pump. Agree? Do you agree with me that all these strings will pump? For p equal to 11, remember, for p equal to 11, these strings will pump. Okay, all of them will pump. All you need to do, what y you will take? You will take y equal to triple a. This y equal to triple a you can take, and they will pump. Now, what about this one? Will this pump? B equal to 20, b power 22. Will it pump? Let's check. W equal to b power 22. 22. B power 22. Will it pump? Okay, remember, within the first 11 symbols, these are the first 11 symbols. These are the first 11 symbols. Here you have to find y. Okay, in the first 11 symbols, you have to find y. Tell me which y will work. Tell me which y will work. Tell me which y will work. Let me know. Let me know which y will work. See, no y will work. Yes or no? Where the problem will happen? Can anyone tell me where the problem will happen? Where the problem will happen? Anyone? The problem will happen if you repeat 0 times. Okay. See here, whatever y you take, please understand, this is w equal to b power 22. This is your string b. This is your b power 22. Now in the first 11 symbols, let's assume these are the first 11 b's. These are the first 11 symbols. Okay. Now you tell me, in these first 11 symbols, you find y. If you take whatever y you want, okay, in this, if you take whatever y you want, then tell me, if you take whatever y, how many b's it will have? Whatever y you take, how many b's it will have? This y. See, in this area, whatever y you take, how many b's it will have? It will have more than, greater than, equal to 1 and less than, equal to 11. Yes or no? Agree? Do you agree with me? Whatever y you take, whatever y you take, it will have these many b's. Now, if you repeat 0 times, in the resulting string, how many b's will be there? In the resulting string, see, if you take this as y, if you take this entire as y, then resulting string will be b power 11. And if you take some other point as y, see, the resulting string can be either b power 11. Agree? Or if you take 10 b's, then which string you will get? If you take 10 b's. So, okay, repeating 0 time is not a problem. Repeating 0 time is not a problem, because see, what you can do, you can take b power 10 as y. See, you can take b power 10 as y. So repeating 0 time is not a problem. Is this clear? See, what you can do, you can take, see, repeating 0 time is not a problem. This repeating 0 time can belong to L. For that, what y you have to take? Repeating 0 times should not be a problem. So what y you will take? You will take this y. Yes or no? Agree? You can take this y. If you take this y and then you repeat, it will belong to the language. Please tell me, is this clear? Let me know. If you take y equal to b power 10, if you repeat 0 times, then you will get b power 12, which belongs to the language. So this string looks like a candidate. Yes or no? This looks like a promising y. Do you agree with me? This y looks like a promising y. Did you understand this? Please tell me. So far, did you understand this? I am saying that repeating 0 time is not a problem. B power 12 belongs to the, B power 12 does not belong, B power 10. So what you can take? If I want B power 10, okay, I cannot create B power 10, right? I cannot create B power 10. So here, whatever y I take, I cannot create B power 10. Okay. B power 10 is the string. B power 12 is not the string. So here, whatever y I take, let me just, okay. See, this is your string, B power 22. This is your string. Just focus now. B power 22. This is your string. In this string, these are the first 11 symbols. These are the first 11 symbols. Okay, now you tell me, in this you will find y. Yes or no? In the first 11 symbols, you will find y. So whatever y you take, how many b's will be there in this? In this y, how many b's will be there? Whatever y I take, in this you will have maximum 11 b's, minimum 1 b. Now you tell me, if I repeat it 0 times, then what are the possible resulting strings? Whatever y you take, if I repeat it 0 times, what are the possible resulting strings? For example, if I take y equal to all the b's, all 11 b's, then resulting string will be b power 11. If I take 10 b's, then resulting string will be what? If I take 10 b's, then resulting string will be what? Then that will be 12. Then that will be 12. Yes or no? If I take only one b as a y, if I take only one b as a y, then what will be the resulting string? If I take only one b as a y, only one b as a y, and I repeat 0 times, the resulting string will be b power 23, 21. And you can notice none of them. See, these are the possible, for different y, these are the possible. Yes or no? Did you notice? See, whatever y you take, please understand, whatever y you take, number of b will be in this y. See, for example, if I take this y, okay, so whatever y I take, in this y, number of b will be from 1 to 11. Okay. Now, if I repeat 0 times, this y, if I repeat 0 times, then these are the possible strings that I can get. Yes or no? These are the possible resulting strings for different y's. These are the possible resulting strings. These are the possible resulting strings for different y's. Is this clear? Please tell me. These are the possible resulting strings for different y's. And did you notice none of them belong to L? And none of them belong to L. None of them belong to L. Is this clear? None of them is belonging to L. So this is what I'm saying, that for this string, this is your string B. This is the string. In this string, whatever y you take in the first 11 symbols, because we are checking p equal to 11. This is what we are checking. So in this area, whatever y you take, remember these are the first 11 symbols. So in the first 11 symbols, whatever y I take, what will happen? You can take whatever you want. If you repeat it 0 times, then I can guarantee that result will not belong to L. I can guarantee that result will not belong to L. So can I say p equal to 11 does not work? Yes or no? Please tell me. So p equal to 11 does not work. Does not work. And who is the violating string? Who is the violating string? Who is the violating string? The violating string is b power 22. Violating string is b power 22. Is this clear? P equal to 11 does not work. Now check p equal to 12. Will it work? P equal to 12. Will it work? Will this work? P equal to 12. Yes, it will work. See, p equal to 12 will work. Notice how. For p equal to 12, these are the candidate strings. First of all, you find out the candidate strings. These are the candidate strings. First of all, these are the candidate strings. Okay. These strings are the candidate strings. Now you can notice all these strings will pump. All these strings will pump. Which y you will take? For these strings, which y you will take? Tell me. Y equal to AAA will work. Y equal to AAA will work. Okay. Now you can notice these strings will also pump. These strings will also pump. Let me tell you. These strings will also pump. For example, b equal to 22 will pump. This b equal to b power 22. This will pump. Tell me what y you will take. I am saying this will pump. This will pump. Okay, in the first 12 symbols. Let's assume these are the first 12 symbols. These are the first 12 symbols. So tell me which y will work. These are the first 12 symbols. In this area, you find y. Okay, so which y is working? Tell me which y will work. Yes, you can take these 12 symbols as y. You can take this y equal to b power 12. Now you tell me, if you take this y equal to b power 12, means your string was this. Your string was this. And in this string, if I take y equal to b power 12, if I take this, please tell me if I repeat this 0 times, what I will get? If I repeat this 0 times, I will get b power 10, that belongs to L. If I repeat it 2 times, what I will get? If I repeat it 2 times, what I will get? I will get b power 34, that belongs to L. You can notice, you can repeat it any number of times, that will belong to L. That will belong to L. Is this clear? Because actually what is this? Tell me, actually what is this? If you take y equal to this, then x will be empty string and z will be b power 10. X will be empty string and z will be b power 10. So tell me what is this one? What is this one? This is b power 12 power n b power 10. Tell me what is this? This is b power 10 plus 12n. 12n. Yes or no? And this is already, it is given that this is a part of the language. Correct? This is a part of the language. This is already given. This is part of the language. This is already given. Okay. So you can notice that this string will pump. What about this string? Will it pump? B power 34. Will this string pump? B power 34. Will it pump? Yes, it will also pump. In this also you can take y equal to, in this also the same, y equal to b power 12. This will work. Okay, y equal to b power 12, that will work. Again, this will also work. So that's it. So finally I can say these strings will also pump. These strings will pump. For these strings you can take y equal to b power 12. And remember, these strings will also pump. These strings will also pump, and you can take y equal to AAA. So every candidate string pumps. For p equal to 12, every candidate string pumps. Every candidate string pumps. Remember, every candidate string pumps. So that's it. Is this clear? Every candidate string will pump. So that's it. So I can say p power 12. I can say p equal to 12. This is a minimum pumping length. Okay, that's it. This is your question. And the answer is p equal to 12 is the minimum pumping length. So can I say every number greater than equal to 12 is pumping length? Is a pumping length? Every number greater than equal to 12 is a pumping length? Yes. Okay, yes. So this is your question. So this GATE exam question we have done. Please tell me, did you understand the complete analysis? If they ask you minimum pumping length, then the question will be interesting, right? If they ask you minimum pumping length, then GoClasses students, they will get some benefit. Okay, yes or no? So that's it. So this is your pumping lemma. We have done practice. Please tell me, are you comfortable with pumping lemma? We have done a lot of practice, and these GATE questions also we have done. So please let me know, did you understand pumping lemma? Are you comfortable with pumping lemma? This GATE exam, one GATE exam question is remaining. So let's see this GATE exam question. This is your GATE 2005 question. What this question is asking? The question is saying that language L satisfies pumping lemma. See, language L satisfies pumping lemma for regular languages, also pumping lemma for context-free languages. Okay, actually, let me tell you. See, this pumping lemma, there is a pumping lemma for regular languages. This type of pumping lemma we have, which is defined for regular languages. Similarly, there is a pumping lemma, a different pumping lemma. Similarly, a pumping lemma, a different statement. Okay, for example, let's call this statement A. Okay, so similarly, there is a different statement. There is a different statement. Similarly, there is a different statement B. Is this clear? Similarly, there is a different statement. Similarly, there is a pumping lemma for context-free languages. Okay, but don't worry, this is not in the GATE syllabus. In the GATE syllabus, this is not there. This is not in GATE syllabus. Okay, this is not in GATE syllabus. But the point is, there is this type of pumping lemma. Okay, so there is a pumping lemma for CFL. If you check the GATE syllabus, you can check the GATE syllabus. Let me tell you, if you check GATE CSE syllabus, in that it is written It is written pumping lemma for regular languages. You can check it out. Pumping lemma for regular languages. It is written. You can check it. So anyway, the point is this is not in the GATE syllabus. This pumping lemma for context-free languages. This is not part of GATE syllabus. But I am saying that there is a pumping lemma for regular languages. This we have already seen. Yes or no? This we have already seen. And there is a pumping lemma. There is a different statement. There is a pumping lemma. There is a different condition for context-free languages. But the point is, what is the point? The same thing happens here. See, tell me, if else satisfies pumping lemma for regular languages, if else satisfies pumping lemma for regular languages, pumping lemma of regular languages, I can say, if else satisfies pumping lemma of regular languages, then what you can say about L? Tell me, if L satisfies pumping lemma of regular languages, what you can say about L? It may or may not be regular. Yes or no? It may or may not be regular, correct? If L satisfies pumping lemma of regular languages, then it may or may not be regular. Similarly, if L satisfies pumping lemma of CFL, if L satisfies pumping lemma of CFL, then it may or may not be CFL. Is this clear? It may or may not be CFL. Okay, so you can notice, if L satisfies pumping lemma of regular, this pumping lemma of regular languages we have seen. This pumping lemma of regular languages, this we have studied. So if a language satisfies this condition, if a language satisfies this condition, then that can be regular, then may or may not be regular. L may or may not be regular. Similarly, there is pumping lemma for CFL. This is not in syllabus. But remember, if L satisfies this pumping lemma of CFL, then it may or may not be CFL. So you tell me the final answer for this question. This is a very old question. Remember this point. This is a very old question. At that time, it is possible that pumping lemma of CFL was in the syllabus. This is very old question. At that time, in 2005, it is possible that pumping lemma of context-free languages, this pumping lemma of CFL, it is possible that it can be in the syllabus. I don't know. But now this is not in the syllabus. I can say for GATE 2024, this is not in the syllabus. But anyway, tell me the answer for this question. Tell me. For this GATE 2025, what is the answer? L satisfies pumping lemma of regular languages. Can you say L is regular or non-regular? L satisfies pumping lemma for regular languages. Can you say L is regular or non-regular? We cannot say L may or may not be regular. Yes or no? L may or may not be regular. L may or may not be regular. And similarly, L satisfies pumping lemma of CFL. So what I can say? L satisfies pumping lemma of CFL. So again, L may or may not be CFL. L may or may not be CFL. Okay, L may or may not be CFL. So your final answer is what? L is necessarily regular? No. Okay, L is necessarily regular? No. L is not regular. L is not regular. L is necessarily CFL? This is also no. L is necessarily non-regular? This is also no. We cannot say anything. Answer will be option D. Answer will be option D. So this is your question. Okay. I hope this point is clear. Okay, so that's it. This is enough. Now, anyone has any doubt, you can let me know. This is complete pumping lemma. We have seen everything. I can promise you one thing. Whatever question comes in the GATE exam, you can solve it. Whatever question they give you, you can solve it. Okay, from pumping lemma. So now, did you understand pumping lemma? Please tell me. We have seen the question, the GATE 2019 question also we have done, and the SIPSR questions we have also done. So we have done enough practice, a lot of practice we have done. Proof we have seen, pumping lemma proof we have seen, all the results that we have seen. Okay, so everything we have seen. Now I want to tell you something. I want to tell you one thing. From pumping lemma, from this pumping lemma, there is only one question if you notice. GATE 2019, right? There is only one question from pumping lemma in the GATE exam. It came in 2019. So I want to tell you that pumping lemma is in syllabus. Okay, if you check the GATE computer science syllabus, it is explicitly given. It is given in the syllabus. In the theory of computation, it is given in the syllabus. Explicitly, it is given that pumping lemma for CFL. Okay. Now, so it is in the syllabus, but there is only one question in the previous year. Okay, in the previous year, in the last 40 years, there is only one question from pumping lemma. There is only one question. So I want to say that if you understood pumping lemma, then very good. If you understood, very good. If you did not understand, don't worry about it. Are you getting my point? There is only one question in the last 40 years. There is only one question, a single question in the last 40 years. So if you understood pumping lemma, very good. If you did not understand, then don't worry about it. Okay, if you did not understand, then do not worry about it. Okay, you can write pumping lemma. If you did not understand, if you have some trouble, okay, if you are not understanding this pumping lemma, if you are not comfortable with pumping lemma, then you can just simply say that don't worry about it, because there is only one question in the last 40 years. Okay, so question can come. Remember, in future, question can come because it is in the syllabus. So they can give you the question, but the probability is very less. Okay, in the last 40 years, there was only one question. So probability is very less, but they can give you. Okay, it is like in GATE 2024, if question comes from pumping lemma, then you cannot say that it is not in the syllabus. Okay, but the probability is very less, very less. So if you want to skip this pumping lemma, you can do that. Okay, if you want to skip, if you did not understand, and if you want to skip, then you can do that. Okay. Okay, thank you everyone. See you tomorrow. Thank you.